This is the next video in the series on u substitution. We're going to focus on u raised to the negative first power, also known as 1 over u du. We already saw in the other videos how to deal with when we get this format. But this one, remember, is for n not equal to -1. So what happens when n is -1? We're going to use that version. And we notice that this is going to be the ln of absolute value of u plus c. So using our steps from the previous video, first thing you're going to do is choose your u. Now in this case, our u is our inside, or, right, if we write that as u to the -1, or what's in the denominator without an exponent, right, or a first exponent. So that's what I'm going to do here. So I'm going to choose u to be x minus 5. Step number 2 was to find the derivative of u with respect to x. So the derivative of x is 1 minus the derivative of 5 is 0. So this is just 1. Step 3 is solve for dx. So du over dx equals 1. And multiply both sides by dx. And du equals 1 dx, or just a dx. So that's what I'm going to use to replace with dx. And just like in the other videos, anything that has a box or circle gets replaced. Everything else that doesn't stays the same. So here is where I'm going to make my substitution. U is x minus 5. So that gets replaced. Dx is du. So that gets replaced. And now I have the exact format I was looking for. So this was step 4 in our process of substitute and simplify. Well, there's nothing to simplify. There's no canceling, there's no reducing that can happen. And so next step is the integrate step. So find the antiderivative of 1 over u. We said that is ln of u plus c. And then last step is substitute back to x. So that'll be the ln of absolute value of x minus 5 plus c. We can always check our results by finding the derivative of it. It better be what we started with. Let's try another. Step 1, choose u. We said it's going to be the inside, or now that we're dealing with, we don't have really an inside. Or if you prefer, right, this is the integral of 6x minus 5 all to the negative first power. That's another way to look at it. Either way, right, this is still our inside. This is what we're going to choose for our u, is 6x minus 5. Step 2, compute du dx. Well, du dx is 6 minus 0, or just 6, right? The derivative of u with respect to x. And solve for dx. We're going to multiply both sides by dx. And we get du equals 6 dx, and then divide by 6. So du over 6 is equal to dx. So that's what we're going to replace for dx. So we're ready for step 4. In step 4, anything that has a circle gets replaced, or a square, or has a different color, if you're using highlighters. So this will be u to the -1, or 1 over u, and dx gets replaced with du. Right? U and dx. Step number 5, integrate. Oops, that's not what I want. Let's try that again. Step 5, integrate. The antiderivative of 1 over u is ln of u plus c. And then last step, I'm going to replace that u with 6x minus 5 in absolute value Take the ln of that and add on a plus c. Okay, so remember, follow your steps. Choose your u, find your derivative, solve for dx, substitute, simplify, integrate, substitute back again. Right? You have your steps laid out. Follow them. Write them out and follow. Let's try another one. Here we've got x over x squared plus 4. And again, if you like, you can write this as x so that they kind of look like the ones we had done before. But remember, we have to notice that because we've got a -1 here, we can't use the other rule. So we're going to choose our u. And it is the inside or the denominator, whichever you prefer. And then we're going to find our derivative. So the derivative of x squared is 2x plus the derivative of 4, which is 0. So that's what we get. Next is solve for dx. So du over dx is 2x. Multiply both sides by dx. And we get du equals 2x dx. And finally, divide by 2x. So du over 2x is equal to dx. That's what we're going to replace for dx, in whichever format you like. So we're ready for step 4. Anything that does not have a circle or square around it stays. Right. So my u gets replaced. And my dx, oops, wrong color. Right? Over 2x. There we go. Took a second look at what I've got in my box there, and so it's a 2x. So now, the simplify step, right, I just slid that 2x over, multiplying fractions, right? And so the x over x is 1. Still need that integral symbol. And so this is what? 1/2 1 over u du, right? Because we've got a 1, we got a 2 left in the denominator, 1 over 2u, if you prefer. And so that's really 1/2 of 1 over u. And step 5 is integrate. So the antiderivative of 1 over u is ln of u plus c. And then last step is substitute back again, right? Take out the u and replace it with, what did we pick there? X squared plus 4. Which happens to always be positive, so the absolute value is a little redundant, but it's fine to leave it in. Right? Got 2 more here for you. Next one, x squared over 3 minus x cubed. So again, we follow our steps. Step number 1, choose u. Right? We notice that 3 minus x cubed, and maybe by now you may be starting to notice that whatever we choose for u, the derivative of it is close to what's left in the problem, right? We're going to end up with a minus 3x squared, if you will. When we do our next step, 0 minus 3x squared. And notice there is an x squared in the problem. So when we do our substitute and simplify, those x squareds will cancel, right? So perhaps you started to notice that going on. So we're going to multiply both sides by dx. And we get du is negative 3x squared dx. And then divide by negative 3x squared. So du over negative 3x squared is dx. And so that's what we're going to replace dx with. Okay. So I circled my u, put a square around my dx. Anything else stays. Anything that doesn't have a circle or a square stays. Right, so that 3 minus x cubed was what we chose for our u. So that gets replaced. And then dx is du over negative 3x squared. And we simplify, x squared over x squared is 1. And I'm left with a negative 3, or a 1 over negative 3. So I'll bring that to the front. Right, just a little bit of the commutative property going on there, and some properties of integrals. The constant multiple property. And so that was step 4. We didn't mark that, step 4. Step 5, find the antiderivative. So 1 over u is ln of u. And then step 6 is substitute. Take out the u and replace it with 3 minus x cubed. Okay, so again, follow the steps. Choose a u, find its derivative, solve for dx, substitute out what you chose for your u and your dx, clean things up, and everything else then is just an integrate and substitute back again. One more. All right, this one may look long and confusing and scary, but it's not. Remember, we've got our steps. Follow the steps. Take comfort in the steps, right? Choose u. So again, right, choose our denominator. And when we do a quick derivative in the next step, we get 3x squared plus 6x plus 9. That happens to be very similar, close to x squared plus 2x plus 3. You might notice if I take x squared plus 2x plus 3 and multiply it by 3, then I get 3x squared plus 6x plus 9. So solving for du over dx, I'm going to solve for dx. So multiply both sides by dx. Du is 3x squared plus 6x plus 9 dx, and then divide by 3x squared plus 6x plus 9 on both sides. So du is, and here's where I'm going to factor out a 3. I'm just going to go ahead and do that. Right. This is all 1. And then that's what I'm going to replace for my dx. Okay, I noticed that 3x squared plus 6x plus 9 had a common factor of 3. And notice when I factor out the 3, I get an x squared plus 2x plus 3. That's perfect. Okay, so what am I going to replace here? X squared plus 2x plus 3 does not get replaced because it doesn't have a circle or square around it. And then I'm going to replace my u, and then replace my dx with du over 3 times x squared plus 2x plus 3. So that was step 4, and I'm not quite finished because I have to simplify. So that over that is equivalent to 1. So this is 1 over u, 1/3 du, right? So du over 3 is the same as 1/3. So this is 1/3 of 1 over u du, the integral of. So we're ready for step 5, which is integrate. The antiderivative, or the integral of 1 over u du, is ln of u. And then last but not least, we substitute back again. What was u? X cubed plus 3x squared plus 9x plus 1 plus c. Okay.